Hello everyone and welcome back to the class. In the previous class, what we have learned: electric current density, drift velocity and current, mean free path and relaxation time, mobility, vector form of Ohm's law. So in today's class, first of all, we will discuss some numerical basis on this concept. Alright. So let's see question number first everyone. The dimension of the conductor of specific resistance rho are shown below. Find the resistance of the conductor across A, B, C, D and E, F. So here we want resistance of this conductor across A, B, C, D and E, F. So first of all, we will find resistance across the AB. Resistance formula already we know that it is rho L by A. This is the resistance formula, correct? So resistance offered by the conductor formula is rho L by A, where L is the length, A is the cross section area. So first of all, we want across AB. So means what is happening? Current is entering from the A and exiting from the B. All right. So if I will write resistance across AB, so it is what resistivity is rho. And now what is happening? Current is entering from A and exiting from the B. So this C is what? It is the length. And what is the cross section area? This is the cross section area when current is entering from the A and exiting from the B. And this area is equal to how much? It is equal to A into B. A into B. All right. Now the next is correct. Now the next is we want resistance across CD. So the resistance across the CD can be written as what? Rho. And now the current is entering from the here and exiting from the D. All right. Now remove this. Current is entering from the here and exiting from the D. So what is happening? This is the rectangle. Now the current is entering from this side and exiting from this side. Correct. So D is present over here on the back side. Here it is present. So here we have C and here we have D. So current is entering from the C and exiting from the D. So when it is entering from the C and exiting from the D, now this B is what? It is the length and this is the cross section. So length is B and cross section is what? It is A into C. This is cross section. So we got it resistance across AB, across CD. Now we want resistance across EF. And this is your homework question, correct? And find out resistance across EF and put your answer in the comment box. All right, note down everyone. Let's see next question. A cylindrical tube of length L has inner radius A while outer radius B. What is the resistance of the tube between its ends, its inner and outer surface? So resistivity of the material is rho. So let's see what is happening in this question. So here we have one cylinder. Length of the cylinder is L and inner and outer radius of the cylinder is given A and B. So inner radius is A and outer radius is B. And the resistivity is rho here. Alright. So we want resistance across its ends and inner and outer surface. So see it first part everyone. Across ends we want means we are connecting battery here to here. So in the first part what is happening? We are connecting battery like this. So current is entering from here and exiting from the here. It is entering from here and it is exiting from this side. This thing is happening. Correct? Okay. So we want resistance, correct? So R1 can be written as simple formula we know resistance can be written as rho L by A. This formula we are using. So current is entering from this side and exiting from this side. All right. So resistivity is rho and length is L. And now this is the cross section. This is cross section for the first part. And what is the area of this cross section? It is pi B square minus A square. So this is the answer for the first part. Correct. Now let's see it second part, B part. The B part, what is happening? Let's suppose this is slender, all right? So current is entering from the inner surface and exiting from the outer surface, all right? And if you will look this slender from the front side, so it will appear like a circle, so inner radius and outer radius already we have. Inner radius is A, outer radius is B. Now next what we will do it, we will consider one ring in this cylinder. Now consider one ring. This ring we are considering, and let's suppose radius of this ring is x. And what is the thickness of this ring? It is dx. Okay. Thickness of the ring is dx. So if I will write resistance for this small ring, so it can be written as dr2 equal to rho, correct? And we want here length also. So here dx is the length, and now we want area, cross section area. So this is slender, current is entering from the here, exiting from the here. So this area we want, correct? This area we want, slender area. So radius is what? It is x, correct? And length of the cylinder is L. So area can be written as 2 pi x into L. This is the area. So resistance offered by this small ring is what? It is rho dx by 2 pi x by L, correct? 2 pi x into L. Now we need to integrate, because we want due to this whole cylinder. So we have to integrate here and think it, what should be the limit of integration? Tell me. Yeah, limit of integration should be a to b, correct? A to b. So now integration of dr2 is what? It is r2, correct? And rho by 2 pi L is constant, put outside the integration. Limit is a to b dx by x. So 1 by x dx, like this we will write. Okay. Now integration of 1 by x is what? Is the log x. A to b is the limit. Put upper limit minus lower limit. So R2 can be written as rho 2 pi L log b by a. Correct? If we will put the limit, so we will get log b minus log a, and log b minus log a can be written as log b by a. So this is the final answer. So across the ends we are getting rho 2 pi L log b by a, and across the ends we are getting rho L pi b square minus a square. Note down everyone. Let's see next question. If the wire is stretched to n times its length, find the new resistance if the original resistance of the wire was R. So in this question we want what is the new resistance, correct? And old resistance is R here. So let's see what is happening in this question. Let's suppose we have one wire and length of this wire is L and the cross section area is A, correct? And resistivity of the wire is, let's suppose, rho. So old resistance of the wire is what? It is the R, and R can be written as what? Rho L by A, correct? Now what we are doing? We are applying some force and we are stretching this wire. Now stretching we are doing n times its length, correct? So new length of this wire will be now Ln. What about the area? Area we don't know, so I am writing here A dash. So we want after stretching n times, what is the new resistance? So new resistance we want here, correct? So new resistance can be written as what? It is rho L dash by A dash. A dash is what? It is the new area, L dash is the new length. So new length already we knows, it is Ln. Old length is L. What about the area? Area we need to find out here. So how we will find this area? Let's see it. We know that volume should be same, correct? Before and after stretching, volume should remain the same. So we will write here initial volume equal to final volume. So what is the initial volume? It is A into L. And what is the final volume? It is A dash into L dash, and L dash is Ln. So now L is cancelling here. So what is the A dash? It is A by N. So new length, new cross section area of this wire is A by N, correct? Now new resistance should be rho L dash is how much here? It is Ln, and A dash is what? It is A by N. Now simplify this, then we will get new resistance equal to N square rho L by A, and rho L by A value already we know, so it is R. It is given in this question. So now the new resistance is becoming N square R. This is the new resistance. So if we are stretching wire n times, then new resistance is becoming N square R. If suppose we are stretching 2 times, then what should be the answer? If we will stretch this wire 2 times, then answer should be what? Then n value is 2, square of 2 is 4, so it is 4R. If I will stretch wire 3 times, then answer should be what? 9R. If I will stretch 4 times, then n value is 4 and the square of 4 is 16, then 16R is the new resistance if we are stretching wire 4 times, correct? So this, now we have here this formula, correct? And this is answer also for this question, but this answer will behave as a formula, correct? Like if you are stretching 4 times, so put here n equal to 4, 3 times, then put n equal to 3, 1.5 times stretching, then put n equal to 1.5 and simplify, then you will get the new resistance. So I hope this thing is clear to everyone, correct? Note down everyone. Let's see next question. The wire is stretched to increase the length by 1%. Find the percentage change in the resistance. So here what is happening? We are increasing length by 1%. Then how much percentage resistance is changing? This thing we want to determine. So this question I am giving to you in a homework. Do it from yourself and put your answer in the chat box. So note down everyone. Let's see it. Next topic, temperature dependence of rho and R. Here rho is representing resistivity and R is representing resistance. One thing already we know from thermal properties of matter chapter. What we know, let's suppose we have one rod and initial length of the rod is, let's suppose, L0, and if I will give some heat to this rod, then final length of this rod can be written as LF equal to L0 1 plus alpha delta. This is final length, correct? So after heating, the final length of this rod is becoming L0 1 plus alpha delta. Here delta is what? It is the change in temperature, L0 is the initial length, and LF is what? It is the final length, and alpha is constant here. So this thing we know from thermal properties of matter chapter. Same thing is happening here also. So resistivity of the conductor at temperature T equal to what? It is rho F equal to rho naught 1 plus alpha delta. So rho F is what? It is the final resistivity. And what is the rho naught? Rho naught is the resistivity at reference temperature T naught, taken as 0 degree Celsius or 20 degree Celsius as a reference temperature, correct? So rho naught is what? It is the resistivity at T naught temperature, and T naught temperature can be 0 degree Celsius or it is 20 degrees Celsius, and this is our reference temperature. Is it clear to everyone what is rho naught and R naught? Something is happening with the R naught also. So final resistance of the conductor at temperature T can be written as R naught 1 plus alpha delta, correct? So this alpha is what? It is the coefficient of resistivity, or we can say that coefficient of resistance also, this alpha. And here alpha is what? It is the positive for the conductor and alpha is negative for the semiconductor. So these points are important for us. So keep these points in your mind, where rho naught is the resistivity at the reference temperature T naught often takes 0 degrees Celsius and 20 degrees Celsius. Now the next point is what? This formula is only applicable when the temperature difference is small. So keep this thing in your mind. It is only applicable if the temperature difference is very small. If it is very large, then this formula is not applicable. Alright, so note down everyone this formula, then we will discuss some numerical on the basis of this formula. Let's see one question on the basis of this concept. The resistance of the thin silver wire is 1 ohm at 20 degrees Celsius. The wire is placed in a liquid bath and its resistance raises to 1.2 ohm. What is the temperature of the bath? Here alpha equal to 10 raised to minus 2 per degree Celsius. So let's see how we can do this question, everyone. We know that final resistance can be written as initial resistance 1 plus alpha delta. This formula we know, correct? So what is the final resistance? It is becoming 1.2. And what is the initial resistance? It is 1 ohm. And alpha is how much? It is 10 raised to minus 2 delta. Now, if you will simplify this, so 1.2 divided by 1 is 1.2 minus 1 is 0.2. So here we are getting 0.2 equal to 10 raised to minus 2 delta. Now delta can be written as what? It is 0.2 divided by 10 raised to minus 2. Now it will go in the numerator, so it is becoming 100. So change in temperature is how much? It is 20 degrees Celsius. Correct? So change in temperature is how much? It is 20 degrees Celsius. Now the next thing is what? Here we want temperature of the bath, correct? So change in temperature of this wire we got it is 20 degrees Celsius. So this change in temperature can be written as what? It is final minus initial temperature equal to 20 degrees Celsius. So what is the final temperature? Final temperature we don't know. Final temperature is depending on the liquid temperature, and liquid temperature we want. And initial temperature of the wire is what? It is 20 degrees Celsius. So now final temperature is, we are getting, it is 40 degrees Celsius, correct? So final temperature of the wire and the final temperature of bath should be same. Is it clear? So that's why the final temperature or the temperature of the bath is what? It is 40 degrees Celsius. So here we want what is the temperature of the bath, correct? So finally we are getting 40 degrees Celsius. So this is the correct answer for this question, 40 degrees Celsius. I hope this thing is clear to everyone how we can do it this question. Note down everyone. Let's see next question. For a material, alpha varies with the temperature as alpha equal to AT square plus BTQ. What will be its resistance at T degrees Celsius if at 0 degrees Celsius resistances are not? So at T degrees Celsius we want resistance here. And alpha is non-constant, it is the function of temperature here, it is varying. Alright. So if I will write here a small change in resistance, so it can be written dr equal to r naught alpha r naught alpha dt, correct? So if I will change dt temperature, then a small variation in the resistance can be written as what? Dr equal to r naught alpha dt, correct? Alpha value already we have here. We want resistance at T degrees Celsius, and at 0 degrees Celsius resistance is R naught. This thing is given. Now what we need to do it here, we will integrate on both sides. Correct? We will integrate on both sides, and limit of integration is what here? We are doing integration with respect to, correct, temperature here. So what will be the resistance at T degrees Celsius if at 0 degrees Celsius the resistance is R naught? So here we are doing integration with respect to temperature, correct? So at 0 degrees Celsius, resistance is what? It is R naught. And at T degrees Celsius, resistance is, let's suppose, R. And at T degrees Celsius, we want resistance here. Alright. Now integration of dr is R, put upper limit minus lower limit. So R minus R naught equal to, here R naught is constant, put outside the integration, 0 to T. And what is the value of alpha? It is AT square plus BTQ. Correct? So now R minus R naught equal to naught, and do it integration of this. A is constant, integration of t square is tq by 3. So here we will get atq by 3 plus bt power 4 by 4. Upper limit minus lower limit. If I will put lower limit is 0, so all things will get 0. Upper limit, if I will put t here, so all things will remain the same. So we have now R naught, I am putting on this side. So we have R equal to R naught plus R naught A by 3 TQ plus P by 4 T power 4. Finally, we are getting this answer. So final, we have resistance at T degree Celsius is R naught plus R naught A by 3 TQ plus B by 4 T power 4. This is the final answer for this question. Note down everyone. Let's see next question. A conductive wire has resistance 10 ohm at 0 degree Celsius and alpha is 1 by 273 degrees Celsius. Then determine its resistance at 273 degrees Celsius. So here we want resistance at 273 degrees Celsius, and at 0 degrees Celsius resistance is 10 ohm is given. Correct? So here difference is very large. That's why R equal to R naught 1 plus alpha delta formula is not applicable here. Correct? So what we need to do it here we will write a small change in resistance dr is equal to R alpha dt. If I will change a small temperature dt, then change in resistance can be written dr equal to R alpha dt. This thing already we know, correct? So here dr by R equal to alpha dt. Now what we need to do it, we will integrate on both sides. We will put here alpha value and we will simplify. Then we will get final answer. So this question I am giving to you in a homework. Do it from yourself and put your answer in the comment box. And if you have any doubt also related to this question, you can ask in comment box. Correct? There I will give reply. So note down everyone. Let's see it. Next topic, Kirchhoff current law. So what is the Kirchhoff current law? According to Kirchhoff current law, net current passing from any junction or node is always zero. So let's suppose here we have one circuit. Let's suppose this is a part of the circuit and this is node here. This is node. So according to Kirchhoff current law, net current passing from this node is what? It is zero. So what I will write here, I net is equal to what? It is zero. And let's suppose I1 current is coming toward this node, I2 current is also coming toward the node, I3 current is again coming toward the node, and I4 current is leaving from this node. So for the incoming current I am using positive sign, and for outgoing current I am using negative sign. So according to Kirchhoff current law, plus I1 plus I2 plus I3 minus I4 equal to 0. This thing can be written. All right, I4 is what? It is the current leaving from this node, and if we will add this all, then we will get equal to 0. All right, and this is the Kirchhoff current law. So now this thing is clear to us. What is the Kirchhoff current law? Now the second important thing is sign convention here, because when we will solve numerical, then we need to use proper sign convention, then only we will get correct answer. So let's see its sign convention. Let's suppose we have one battery and we are applying KVL from left to right. We are going from lower to higher. Then we will write plus V. Now again we have battery. Again we are applying KVL left to right, but now what is happening, we are going higher to lower, then we will write minus V. Alright, so this sign convention we will use for the battery. Now if suppose here we have resistance and current is flowing left to right, current is flowing here left to right, and we are applying KVL again left to right. So in this case what will happen, potential will drop, minus sign we will use here. When the direction of current and direction of applying KVL is same, the negative sign will come. Now in this case what is happening, current is flowing right to left and KVL we are applying left to right. So in this case what will happen, the current and applying KVL direction is opposite, that's why we will write here plus IR. So in this case potential is increasing. So this sign convention we are assuming, correct? So same sign convention we will use in numerical also. Alright, note down everyone. Now let's see one question on the basis of this concept. Determine the current flowing through each branch of the circuit. So here in this question, we want current flowing from each branch, correct? So how we will do it, this question, let's see it. We will simplify this question with the help of Kirchhoff current law. So in this method, what we will do it, at any one point, we will assume zero potential. So I am assuming here potential is zero. So if 0 is here, then here would be what? It will be also 0. And here if I am assuming 0, then here will be also 0, correct? Alright. So with respect to this point, what should be the potential at this point? At this point, we are going higher to lower, then definitely potential should be decreased, then here should be minus 10 volt. And here if we have 0 volt, then here is how much? We are going from lower to higher, then here is plus 2 volt. Correct? We don't know here how much potential, so assume it here the potential is X. And if I am assuming here is X, so at this point should be what? It should be X minus 1. We are going higher to lower, that's why. So now we have potential at every point. Alright. Now let's suppose from this X node, I1 current is going in this direction, I2 is going in this branch, and I3 current is going in this branch. According to KCL, net current passing from this node should be what? It should be 0. Correct? So summation of I1 plus I2 plus I3 equal to 0 according to Kirchhoff current law. What is the I1? According to Ohm's law, we know that V equal to Ri. Means I equal to what? V by R. Means if we know potential difference across this R1 resistance, and if I will divide this potential difference with the R1, then I will get current passing from this 1 ohm resistance. So this is R1, and let's suppose this is R2 and this is R3. Correct? So I1 can be written as what? It is the potential difference across the R1, which is X minus minus 10. So it is X plus 10 divided by R1. R1 is 1. Now what is the I2? I2 is the current passing from this R2 resistance. Potential difference across this R2 is how much? It is X minus 2 divided by 1 plus R3. The current passing from this R3 is what? It is I3, and potential difference across this R3 is how much? It is X minus 1 minus 0. So it is X minus 1, and the resistance is R3. R3 is 1, and it is equal to 0. Now simplify this. So if we will simplify this, then what we will get? X plus 10, X minus 2, X minus 1. So it is 3X, correct? And here we will get plus 7 equal to 0. So now X equal to what? It is minus 7 by 3 volt. So now we got it potential at this unknown node, correct? Unknown potential we got it at this node. Okay. Now we want I1, I2, I3. So what is the I1? I1 is X plus 10, correct? This is what? This is the I1. This is what? This is I2 and this is I3. So I1 can be written as what? It is X plus 10 by 1. X value is what? It is minus 7 by 3 plus 10. So how much we will get? Minus 7 by 3 plus 10. If you will do it, then it is 23 by 3 ampere. 23 by 3. ampere we will get. Okay. Now let's see it I2. What is the I2? I2 equal to what? It is x minus 2 by 1. And x value is how much? It is minus 7 by 3 minus 2. So it is how much? It is minus 13 by 3 ampere. Now let's see it I3 value. X minus 1 by 1. X is minus 7 by 3 minus 1. So it is minus 10 by 3 ampere. So now we got it I1, I2, I3, correct? So from every branch, correct, we got it current, and this is our final answer. I1 is 23 by 3 ampere, I2 is minus 13 by 3 ampere, and I3 minus 10 by 3 ampere. So from each branch we got it current right now. Note down everyone, then we will move for the next question. Let's see next question. Find the potential at point A. So in this question, we want potential at this A point. So we don't know what is the potential at the A point. So we are assuming at A point potential is X. All right. So with respect to this A point here, potential should be X minus 15. Correct. And if here is X, so at this point, potential should be X minus 20. Is it clear, everyone? Here potential is minus 50 volt. So here potential how much? It should be minus 45 volt. Is it clear? All right, we are going in this direction. So potential is gaining. So that's why here should be how much? It should be minus 50, minus 45 volt. Okay. So according to Kirchhoff current law, here we are using Kirchhoff current law, KCL we are using. So according to Kirchhoff current law, if I will apply this law at this A point, so according to this law, net current passing from this node A should be 0. So I net is 0. And let's suppose from this A point in this direction I1 current is coming, in this direction I2, here is I3, and this is I4. Correct? Now, if we will add this all the current, so it should be equal to 0, then I1 plus I2 plus I3 plus I4 equal to 0. Correct? If I will add this all the current, so it should be equal to 0. Now this I1 current is passing from this 2 ohm resistor. Let's suppose this is the first, this is second, this is third resistor, and this is fourth resistor. So this I1 current is passing from this 2 ohm resistor. So if I will write I1, so what it can be written as? Potential difference across the 2 ohm, which is X minus 15 minus 20 divided by 2. And what is the I2 value? I2 can be written as what? It is X minus 20, correct, minus 10 divided by 1. Now I3 current is passing from this 1 ohm. So potential difference across this 1 ohm can be written as X minus X minus minus 30. So it is plus 30 divided by 1. Now I4 can be written as what? X minus 45. So it is plus 45 divided by 2 equal to 0. All right. This thing we are getting. Now the next thing is what? X minus 50 minus 20, it is minus 35 divided by 2 plus X minus 30 divided by 1 plus X plus 30 divided by 1, X plus 45 by 2 equal to 0. Now next thing is what? Multiply with the 2. So if we will multiply with the 2, then what will happen? X minus 35 plus X minus 30 plus X plus 30 X plus 45 equal to 0 we are getting. Now simplify this. Okay, and we are multiplying with the 2, so it is 2x, this is 2x. So when we are multiplying with the 2, so it is 2x and this is minus 60, and here we have 2x plus 60. This thing we are getting, correct? This thing we have. Okay, now this minus 60 and plus 60 will get cancelled out. Okay, this is 2x, 2x, x, so 4x, 5x, 6x. So we are getting here 6x minus 35 plus 45, so it is plus 10 equal to 0. So x equal to, we are getting minus 10 divided by 6, so it is x equal to minus 5 by 3. So what we are getting finally, x equal to minus 5 by 3 volt. So potential at A point, what we got it is minus 5 by 3 volt. This thing we are getting. Alright, so at the A point we got it potential. So like this we can do it this question, and if we have this type of similar question, so like this we can approach. I hope this thing is clear, everyone. Note down. Let's see next topic, Kirchhoff voltage law. So what is the statement of Kirchhoff voltage law? The algebraic sum of all the potential differences along a closed loop is 0. And Kirchhoff voltage law is based on energy conservation. Keep this thing in your mind. Now let's see how we will apply this Kirchhoff voltage law in closed loop. So let's see one example, then you will get clarity how we are using this Kirchhoff voltage law in closed loop and how we are getting 0. So here we have one resistance, then we have one battery, then here again we have one resistance, then here we have one battery. So this type of closed circuit we have, correct? This is R1, R2, EMF of the battery is E1 and it is E2. So now we are applying this Kirchhoff voltage law in this closed loop, correct? We are applying this KVL in clockwise direction. So we are starting from the A point. This is A point, and let's suppose potential at this A point is VA. Then we are moving in clockwise direction, and let's suppose I current is flowing in this closed loop. We are considering I current is flowing. So here we have one resistor and direction of current, and we are applying KVL in same direction. That's why we have negative sign. When the direction of current and direction of KVL is same, then minus sign will come. This thing we know. So minus IR1. Then further we will move, then we have one battery, we are going higher to lower, then minus E1. Further we will move, then we have resistor here, then minus IR2. Then again here we have one battery, we are going lower to higher now. That's why we will write plus E2. Now we are at this A point, so equal to VA we will write. Now VA is cancelling, then what we have, minus IR1 minus E1 minus IR2 plus E2 equal to 0. So we got it now 0 here. So this is closed loop and we are getting 0 also. Correct? So note down everyone, then we will discuss some numerical on the basis of this KVL. Now this thing is clear how this KVL can be applied in the closed loop, correct? Let's see one question on the basis of this concept. Find Vy minus Vx in the circuit shown below. So here in this question, we want potential difference between X and Y point. So between X and Y, we want potential difference. So let's see how we can do it this question. Here we are using Kirchhoff voltage law, KVL, correct? And we are moving from X to Y. So X to Y, we are applying here Kirchhoff voltage law, and current is also flowing from X to Y, correct? You can see it in this picture. So let's suppose potential at the X point is Vx. We are starting from the X point. So potential at the x point is Vx. Now here we have resistance. Direction of KVL and direction of current is same. That's why we will put here negative sign. Then 3 into 1. Then we are going from higher to lower, then minus 5. Then here we have one resistance, then minus 1 into 1. Then here we have one battery, higher to lower we are going. That's why we will put here negative sign. Then here we have battery. So here we will put negative sign, and 2 into 1 we will write here, equal to Vy. Correct? So this thing we are getting. Now the next thing is simplify this. So minus 3, minus 5, minus 1, minus 5, minus 2 equal to Vy minus Vx. Correct? So finally what we are getting after simplification, it is minus 16 volt. And this is the final answer for this question. So I hope this thing is clear when we have this type of question, then how we can simplify, correct? And how we are using KVL here. So note down everyone, then we will discuss next question. Let's see it. Next question. In the part of the circuit shown in the figure, the potential difference Vg minus Vh between the point G and H will be. So here in this question, we want potential difference between G and H point, correct? Potential at the G point is, let's suppose, Vg, and the potential at the H point is Vh. So this potential difference we want, correct? So first of all, analyze this circuit. What is happening here? So here we have 4 ampere current. This 4 ampere current is passing from this 4 ohm. Then here we have one battery. Same current present here also. It is 4 ampere. And how much current is passing in this 2 ohm, we don't know. Correct? And from this battery also, how much current is passing, we don't know here. But this current and this current is given here. It is 2 ampere and this is 3 ampere. If I will apply Kirchhoff current law, KCL, if we will apply at this node, so from this node 5 ampere current is leaving. So 5 ampere current should be enter on this node, correct? So on this node 5 ampere current is entering. So from this node definitely 5 ampere current should be exit, correct? Now see this node everyone. Here on this node 4 ampere current is entering, correct? So 4 ampere current is entering on this node and 5 ampere current is exiting from this node. So 1 ampere current should come on this node, then only it is possible. So now like this distribution of current is happening, correct? Anyone having doubt here? So now we have current, all right? So now we will use here Kirchhoff voltage law from G to H, and we will choose this path here. This path we will choose, correct? So potential at G point is Vg. Then we have one resistor. Resistance is 4 ohm. Current is passing 4 ampere. And direction of KVL and direction of current is same. So minus sign we will write 4 into 4. Then further we will move. Then we have one battery. We are going lower to higher. That's why plus 2. Then here we have one resistor. Minus 2 into 4. Then further we will move. Then we have 2 ohm resistor. Current is going in upward direction. We are moving in downward direction. Both are opposite. That's why we will put here positive sign. Plus 2 into 1. And now we are at this H point. So it is equal to Vh. Correct? Now simplify this. And what we want Vg minus Vh. So Vg minus Vh equal to plus 16 minus 2 plus 8 and minus 2, correct? So how much we are getting after simplification? It is plus 20 volt. So finally potential difference between G and H, how much we are getting? It is plus 20 volt. This is the final answer, correct? Plus 20 volt. So note down everyone, and let's see one more question. So in the next question, what is happening here in the circuit shown in the figure? If the potential at the point A is taken to be 0, the potential at point B we want. So potential at A point we are considering 0, correct? And at B point we want potential in this question. So again here use KCL and KVL and simplify this question, correct? when you are applying KVL from A to B, then you have total 3 paths. If you will think, so we have this path, and this path also. Total we have 3 paths, correct? If I will choose first number path and I will move from A to B from this first path, then what is the problem? R1 and R2 is unknown, correct? It is not given. And if I will use second path, then here this resistance is given, potential of the battery is given, correct? And if I will use KCL, then I will get current passing from this 1 ohm also. Alright, so all things are given. Now see third path. If I will use third path, then what is happening? Then we don't know how much this resistance. Then again it is unknown, correct? So if I am using first and third path, then resistance value we don't know, correct? Because this is unknown. But if we will use second path, then all things are given. So we should use here second path, then only we will get the answer, correct? So this is hint for you how we can approach this question. All right. So this question I am giving to you in a homework. Hint already I given to you, correct? Whatever answer you got it, you will get. Put your answer in the comment box, correct? And if you have any doubt related to this question, you can put in the comment box, then we will discuss about that. So note down everyone.